in our projects, like, we did plumbing soil line, waste line, correct. Then cold water supply. Then hot water supply has completed. Then hot water recirculation has completed. Centralized water heater we have placed. Booster pump connection, the hookup. This valve connection is called a hookup. Hookup has completed. Then inlet line, bypass, overflow, that has done. In HVAC also, like air conditioning and ventilation, correct. So indoor equipments, we have placed fan coil units. Then VAV connection has done. So this one is a cooling plus ventilation for the common area. And AHU we have proposed. This is only for ventilation mixing, no, 2030 mixing FAH also we have placed. Now, the remaining things is chilled water. So I'll be connecting with the chilled water. So the first we have to place the chiller. Suppose if it is an air-cooled chiller, the completely we can place it in the roof side, no problem. We can place it in the roof side. But if it water-cooled chiller, normally chiller, barely we will be placing this on the roof side. We'll be placing that on the plant room only. Chiller plant room, most probably it might be on the basement, or sometimes for huge projects, like we might be having separate plant rooms that might be located slightly far away. It means sometimes it might be near, or sometimes it might be just less far away from the building. Okay, so how much space we require for a plant room? Roughly, because anyhow, plant room is an architectural or civil construction. Minimum the floor height from the finished floor level to the bottom of slab or the bottommost obstruction. Suppose if you are having a beam, clearly from there 4.5 to 5 meter height you need within the plant room, because then only the material handling within the plant room will be easy. And also the proper air circulation we will get inside. Correct. So how much floor area, what should be the dimension of a plant room that we required minimum? As a thumb rule, we are having like 5 square meter plus 0.5 square meter per ton of refrigeration. 5 square meter is a normal value, plus each ton of refrigeration 0.5 square meter you can consider. Like that, the floor area requirement for plant room we can find. Chiller plant room I am saying. Other cooling tower, how much if it is diesel room or electrical room, how much we required, DG room, how much we required, that separately will come. For chiller plant room, here I am planning to propose like water-cooled chiller only. So, water-cooled chiller, we have discussed in the previous classes, right? We are having like a primary only system, variable primary system, primary secondary system, primary secondary tertiary systems. I'll be using primary secondary system only. So primary pumps will come, secondary pumps will come. Then for cooling tower separate, this is a water-cooled chiller cooling tower separate system will come. So how much space we required? Anyhow, roughly, if it is an Indian project or it's a non-insulated wall if you are using, barely like 140 square feet, as a thumb rule, you can consider 1 ton of refrigeration. But as you know, how to do the heating and the cooling load calculation using HAP software, or how to do that by E20 sheet, that we have already studied. But once the project is starting, sometimes the architect might be asking, okay, what might be the minimum dimension that you required for a plant room? Accordingly, only they will be considering the space for this plant room. So once the project is starting, we might not be having that much time to do the heat load and all. So roughly, we have to give the dimension data, how much floor area we required accordingly. We have to give the data to the architect. Accordingly, they will be making it. Correct. That's why this thumb rule is not for the project. Thumb rule is just to find the dimension or find the floor area of plant room. But when we are doing the project, you know how we are doing all these things. How we have to do the heating and the cooling load calculation using HAP or E20 method. Accordingly, only we will be selecting the machine and we will be doing it. The same way only we did that. Correct. That's why, but when you are working in a company, after the feasibility study, when we are doing the in-house meetings, we have to give this input to the architect. They will ask the rough dimension of the plant room. Okay, rough dimension of plant room, then how to arrive it. In that scenario, you can do one thing. It might be slightly oversizing, but even though there is no problem. what's the dimension of this building? You know that this is like a 30 meter by 25 meter, 4-story, ground, first, second floor. Okay, so the floor area will come, floor area is 30 meter by roughly 25 meter, 750 meter square, multiplied by 10.765, a single floor area in square feet. And you can consider 140 square feet, 1 ton. In the starting, as I told, not to do the project. You should not follow the thumb rule method when you are working in a company, because thumb rule method might be slightly oversizing or undersizing it. This one, just to find the or give the data to the plan room, we are following this one. Okay. This 8,000, always use HAP or E20 when we are doing the job. HAP will be accurate. Okay. This 8,073 square feet will come. Each 140 square feet, you can assume 1 ton. So divided by 140, a single floor will come 57 ton. 57 ton. Like that, we are having 4 floor, ground, first, second, third. 230 tons can come. So 230 tons air cooled chiller will be more than sufficient. Up to 200 or less than 200 DX we can check. 230 air cooled chiller might be fine, but we have to cross compare it, whether which one is having the least initial investment, running cost, lifetime, energy efficiency ratio, COP, which one we are getting out of DX, VRV systems and air cooled we can select. But I will be, since it is continuous working 24/7 building, definitely water cooled chiller will be good. So I'll be explaining the water cooled chiller for that. Okay. So 230 ton can come. So now we can find the area, as you know, 5 square meter. So 5 square meter is common, plus each ton of refrigeration 0.5 square meter. So 230 into 0.5. So 230 ton of refrigeration into 0.5, 115 square meter, 115 square meter plus 5, correct. Means 5 square meter plus 115. Overall, we need 120 square meter, correct. So 120 square meter. Suppose when you are taking the square root of this one, you will be getting the dimension. Let's say you'll be getting 10.9 by 10.9 on 11 meter by 11 meter. Or you can make this as like a 10 meter by 15 meter or 10 meter by 15 meter, your choice. Like that, you can arrange it. Approximately, anyhow, we need 120 square meter, 11 meter by 11 meter area we required for plan room. Okay. So let me make that roughly. Then this data we will be giving to the architect. Architect will be doing it. For this shaft, I will be using for chilled water, and I will be selecting a floor. Okay. Even if I am on architect mechanical discipline, I will be making a floor. And let me select it like this side. I'll be making as 11 meter. The same way, this side I'll be making slightly more. Let's 11 only will be sufficient, like 12,500 I'm making. Okay. This is a minimum floor area requirement, but you can increase it. Minimum floor we need from the ground floor. Minimum floor we require this much, then finish it. Okay. So this is a floor I have considered. In this floor, they can make their architecture, but they will be doing it. Since my discipline is mechanical, that's why it is not visible clearly. But here only I'll be placing my chiller and all. I'll be placing a screw chiller. So let me load my necessary things. I'll be selecting my chiller, primary pump, secondary pump, cooling tower, everything. Okay. So let me load it. I'll be going to the systems. Okay. From the system under mechanical equipment, go to load family. Let me select the chiller. I'm just going to our folder, mechanical, MEP, waterside component, chiller. Okay. If the manufacturer has provided their data, that one you can select. I'll be selecting a screw chiller water cooled. Okay. Let me select this one. The medium range one, 623 kilowatt, somewhat near to 230. Okay. This one. And I'll be placing 2 duty, 1 standby, 3 chillers I have placed. When you are selecting the chiller, you can see this is 10 mm outlet, 10 mm outlet. This is the drain line only. And 130 mm in, 130 mm out. What is that? You can click it. For example, this one. That is your hydronic supply only. Okay. And this one. That is hydronic return. Means 2 lines. One is for evaporator. The next one is for condenser lines. The chiller 4 lines. The same time, I have to place my pump. Let me load the pump. I'll be going to the mechanical equipment, load family. I need waterside component, pump, a base mounted pump I'll be selecting. Okay, base mounted pump. Let's see. This one we can select. And same time I need secondary as well. And also I need a cooling tower as well. 3 pumps I have selected. Okay. And I'll be making this as, this one I'm going, go to edit type, duplicate it. I'll be making that as primary pump set. Primary pump. Okay. Okay. And this two also I'll be making as primary pump. And this one I'm just going to edit, duplicate. Let's say that is my secondary pump. Okay. Okay. This two also I'll be selecting and changing into secondary. And this one I'll be changing into cooling tower pump, CT pump or condenser water pump. Click OK. So this also I'll be changing into cooling tower pump. Okay. Fine. Now, in the chilled water primary pump selection, secondary pump selection, the chiller classes, we have already studied how to select the primary pump, secondary pump, chiller, how to size these lines and all. We have already studied it. And in the chilled water circuit classes, we have studied when we are using the pump for the chiller, manifold arrangement we can use, manifold pumps we can use. Means, for example, when you are providing the chilled water primary loop, we are having single pump option. Means if this is your outlet, sorry, the inlet to the chiller, here we can use a single chiller, single pump. Single pump connection will be there, but the disadvantage is even if 1 or 2 chillers are not working, then the pump will be like adjusting the RPM will be difficult even if there is VFD. So that is not economical. The next option we can go for manifold pump. Manifold pump means, for example, 1 or 2 pump we will be having there. Okay. From the chiller return, it will be taking it. And after that, it's a header. Then it will be connecting to this one. It's not dedicated. 1 or 2 pump set we will be arranging like if it is beyond 5 HP, then duty standby. We will be arranging like a duty standby arrangement. Accordingly, with respect to the demand, the pump will be working. That is called a manifold arrangement. But each chiller we will be having separate pumps. Okay, that is called what? That is called a dedicated pump. Dedicated pump, if the chiller is not working, the pump will be also turned off only. That will be easy to adjust, and also that is. But the number of pump might be more in that scenario, but even though that is energy efficient arrangement only. So I'll be going for dedicated pump only. Each chiller I'll be proposing separate pump. Okay. Anyhow, let me select the chiller. Now the diameter is 130 only. I'm just going to the edit type. Cooling water supply and cooling water. Actually, this is cooling water means chilled water. Cooling water is cooling tower line. Chilled water means chiller line. Anyhow, chilled water supply diameter for time being, I'll be, with respect after the chilled water pipe sizing, we can do that. We already did that for all the projects, like when we are doing the AutoCAD. Chilled water supply, let me select it. That is like for time being 100. I'm not just making like a smaller one. Anyhow, roughly how much? 200. 250 ton of refrigeration. We might be required beyond that. We can size it, right? What diameter will come? For example, if it is after the heat load, how much ton of refrigeration if you are getting with respect to like 100 Pascal per meter to 400 Pascal per meter, maintain the velocity up to 50 mm pipe, 1.2 meter per second or 4 feet per second. Above 50 mm means from 65 mm onwards, the velocity maximum you can go up to 3 meter per second or 10 feet per second. Based on that, from either from the X-ray graph you can do that or by the help of pipe sizer. I'm not repeating that process again. Okay, chilled water diameters I'll be selecting like this, 100 mm. And cooling water, 130 is not a standard diameter. After 100 mm, 125 only we are having. After 125, 150. So that's why cooling water supply, I'll be making this as 125. This is for condenser line only, and this is also 125. Okay. If you want to decrease the dimension, then you can do that. Okay. Anyhow, the minimum distance in the chiller circuit class we have studied in chilled water system. Distance between the chiller, at least 1.5 meter you have to maintain, 1.5 meter. So let me select it, 1.5 meter. For example, this one I am selecting, align this one and this one. Anyhow, from there, minimum 1.5 meter I need. I am selecting this one. Move option. With respect to there, I need a distance of 1500. Okay. The same way, let me select this 3. This also I will be roughly aligning now. Then select this one, move with respect to any point. Okay, I need like 1500. Okay. So now you can move this. And for time being, I'll be mirroring it. Mirror. Okay. I'll be deleting this one. All these 3 I will be moving to this side where I'm having the convenience. Okay. So I can connect all this. For example, if you want to provide separate color for your pump and all, you can do that. For example, I'm just going to the primary pump. Okay. I'm just going to the primary pump. Go to edit type. Okay. And after that, you can go to the pump material. From the pump material, you can go to the appearance. Okay. From the appearance, let me select a new color. I'll be selecting a create new material. Let it come. Okay. New material has to come. Anyhow, it is consuming like more graphics since the number of components are more here in our project. Okay. And let me select it, create new material. Let's say default material I'll be renaming into primary pump. Okay. Primary pump. And this primary pump color I'll be providing like this one. Okay. Apply. Okay. Apply. Okay. You can go to 3D. You can see the color got changed. The same way secondary pump if you need separate one. This one is like a secondary pump only. Okay. Go to edit type. Okay. Now you can go to the pump material by category. So I'll be creating a new material. So that one is my secondary pump. So for this secondary pump under appearance, we need a separate color like this one. Okay. Play. Okay. Apply. Okay. Okay. Now you can give a separate color for your cooling tower pump. Just go to edit type, This one, let's say create a new material, default new material, I'll be renaming like a cooling tower pump. So cooling tower pump, what color you need, that one you can provide. I'll be providing, let's say this color. Okay, apply. Like that in chiller, if you want to give a separate color, you can. Okay. Now I'll be going to this one. You can make realistic, that will come. Okay. You can go to the piping system, and now the pipe has to be selected. The pipe material that we are using will be Schedule 40 steel pipe only. Schedule 40 steel pipe. So I'll be going to under the schedule, family, piping system. Piping system. Okay. Domestic cold water, domestic hot water is there. Fire protection. We need hydronic supply and hydronic return. Okay. Two more thing I need. This one I'll be renaming, or two more thing you can duplicate. I'll be duplicating, and hydronic supply I'll be duplicating. Okay. So this one, hydronic supply is chilled water supply only. I'll be selecting this one. Just under the graphics override, you can go to the edit. Which color you need, that one you can select. I'll be selecting this color. Okay. When I'm making this single line, I need a solid line. Okay. Hydronic return is chilled water return. I'll be going to the graphics override, edit it. And the color I need this one. When I'm making single line, it should be a solid line, not dotted one. And this hydronic return, hydronic supply, I'll be right clicking and renaming as cooling tower supply. Cooling tower return. Okay. Cooling tower supply, you can provide a separate color. And the cooling tower return. So which one you like, respect to the company, you can take it. Okay. Now I'm just going to the system. I'm selecting the pipe. As you know, up to 50 mm dia pipe material, the joint should be welded. Joint should be threaded. All the fittings should be screwed connection. Above 50 mm means about 2 inch, 2.5 inch onwards, 65 mm onwards, that should be welded only. Okay. For time being, when you are selecting pipe category, we are having chilled water section. So I'm selecting a chilled water, hydronic return or hydronic supply, whatever it may. And the two new system that I have duplicated is also there. I'm selecting hydronic supply. Carbon steel is the pipe material I'm getting, fine. If it is copper, you have to go to the edit type, you have to change it. And I'm selecting this one. When I'm making my pipe, I'm getting this joint. Fine. It is a standard elbow only, that is fine. But the pipe diameter above 65 mm, I need a flanged type elbow or I need a welded type elbow. Okay. Separately I need. That's why that has to be changed. Okay. It has to be changed. I'll be selecting the pipe section. The chilled water, you can use the same. Otherwise, I'm just going to the edit type option. Go to the duplicate. I'll be selecting my own chilled water supply or chilled water pipes. I'm creating my own system. My own pipe. This is my chilled water pipe only. I'll be changing that into chilled water pipes. Okay. And I'm just going to the edit type. From the routing preferences, I have to make sure that the pipe material is schedule 40. But here you can see under the pipe segment, first material is copper only. For example, 8 mm to 25 mm. 8 mm to 25 mm, that is copper. 32 mm to 600 mm, that is carbon steel. But anyhow, first pipe material I'll be selecting schedule 40 carbon steel. Minimum size 50 mm. 15 mm to 50 mm. That should be carbon steel only. Now, the second option, 65 mm to 600 mm. But if you want to add any sizes, you can go to the mechanical settings. Under the manage category, you can do that MEP settings. Otherwise, you can go to the segments and sizes. The same, this is mechanical settings only, MS. Under the pipe setting, segment and sizes, if you want to add anything, you can add it from here. If you want to delete anything, you can. For example, maximum diameter is 600 now. If you want to add 700 or 800, you can select a new and you can add it. Okay. Nominal diameter, ID, OD. We can get that from the schedule category. Okay. The same way, elbow 15 mm to 50 mm. I need the normal one, standard, fine. But above that, I need welded or flanged one. But flanged one is not there, so no problem. We can load it. I am just going to the load family. Okay. Under pipe section. Okay. Fittings. Carbon steel. Class 150. Flanged one. So the elbow, I need elbow long radius. These are flanged one. This one I am selecting. Elbow, flanged one. Okay. Open this one. Now you can see up to 15 to 50 mm, that is fine. Then from 65 mm to 600, fine. I need flanged one. Elbow flanged one only. Click OK. Apply. OK. Now I'll be selecting the same pipe. Create similar. Let's say if the pipe diameter is 40 mm. I'll be getting this one. Then create similar. The pipe diameter is 150 mm. When I am making, I am getting this one, this elbow. So that's why with respect to the diameter ranges, we can change it. Okay. This is flanged type only. You can go to the edit type. Okay. Now, if you want to add more diameter ranges, no problem. You can click here, and after that, more diameter ranges you can add from there. Correct. You can add or you can delete. Okay. So anyhow, now the same way, preferred junction is T only. Now for junction also up to 15 to 50 mm, that will be this one. Then from 65 onwards, 65 to above, that should be a flanged one. Junction, I need a flanged one. So you can load family. All these one, I'll be selecting together. Click open. Okay. Let me load it. So junction, I'll be selecting flanged one. T. Okay. Now the cross also 15 mm to 50 mm. We can use this one. Now 65 mm to 600 mm. I need that is flanged one. Transition also 15 mm to 50 mm. That should be this one. Okay. Now the 65 mm to 600. I need flanged one. Okay. Union, that is common. Okay, no problem. Flange for the this one 15 mm to 50 mm and 65 mm to 6 above that. This one I need the standard. Keep it there. Cap or end cap. That is fine. Flanged cap also we can load. Click OK. Apply. Okay. Now you can select this. Create similar. Check it. This is pipe diameter higher than that. You will be getting what type of fittings like this. You will be getting it. Okay. So my pipe is ready. Okay. Now let me make this is my this one I'll be secondary pump I'll be moving for time being. This also keep it there. And all this slightly I'll be moving there. And you can go to this one. 100 mm is when you are selecting it, it will ask what diameter you have to select. For example, hydronic supply 100 mm means chilled water supply. This is chilled water return. Okay. First, we can make the primary. What the primary pump will do? From the building side, chilled water circuit we have to make, we can make it. So the primary pump will be taking the suction from the building side and it will be sent into the chiller. Okay. So that's why I'll be making like this. This is my first primary pump. And that's another one. The third one. Okay. So the primary pump, I'm just going to edit it. And the diameter, suction and delivery, with respect to a real case, it will vary. For time being, I'll be changing that into 100. Delivery also, we should change that. Suction is 100. Discharge also I'll be making 100. Okay. And from the chiller, I'm just making a section here because I have to provide foundation and all. For all these three chiller, from the ground floor level, 200 mm foundation I am providing. Pump, it is not mandatory since it is already having a base. We don't want to provide it. Okay. So this is my chiller. So normally primary pump suction is this one. That is this one. This is primary pump delivery. Okay. And when you are selecting your chiller, you can see the chiller 100 mm outlet, 100 mm inlet, chilled water return. So the primary pump will be taking the return from the building and it will be connecting to the chiller inlet. It has to connect it there. But this line, this pipe, I'll be taking vertically slightly upside because here we have to connect our fittings. That's the reason. So from here, I'll be making a pipe. If you are getting sufficient distance, that is fine. Otherwise, to connect the valves and all, we need minimum distance there. That's why. I'm just going to the ground floor again. Okay, now we can align it. I'm just going to the align option. Align this one and this one. Aligned. Okay. But if I am taking this pipe 2 down, we will not be getting enough space there to connect. Correct. So that's why you have to make it slightly upside. In this vertical line, we can connect the standard pump fittings. Now I'll be taking like this. Then I'll be connecting it. Okay. Chiller return only, but no problem. When we are connecting it, it will be changing it. Okay. So primary pump will be taking the suction through this way, and the primary pump will be delivering the water to the chiller. This connection I have to make in the other chiller as well. So let me move this one here. This is my primary pump suction and the primary pump delivery. Same time. Okay. Just go to align option, this one and this one. Okay, this side has aligned. When you're selecting chiller, we can see there is 4 lines. This one is 100 mm outlet. This is chilled water supply only. Secondary has to take the connection from there. This is chiller inlet. Means return only. So this hot water will be entering there, means nearly 13.8 degrees Celsius of water as per ASHRAE 90.1. And these 2 lines are cooling tower lines, so condenser water lines. Okay. Now align this one and this one. The same time, top side also has to be aligned. This one and this one. Now you can connect it, trim and extend. Okay. Now the third one. So this is primary pump suction, primary pump delivery. This side we can align. You can go to here, align this one, make it like trim and extend, connected. Now slight adjustment I have to make. Okay. Now from the chiller to the backside, at least 1.5 meter I required. There. Yeah, that is fine. This one, I'll be slightly moving this way. But since it is a dedicated pump, that's why the connection is coming like this. And yeah, this one is your flange only, fine. And the pump, 1 second. Let me move it. Okay. The height we can adjust later. I'll be moving there. With respect to that one, we can align it. Align this one to here, this one to here, this one to there. Okay. But if the height has to be increased, we can do later. Align this one to here. All the pumps are at the same level. When we are connecting to the corresponding pipe, that will be varying. Now in the standard pump fittings, we have to provide there. Still, if we can move it, if we require to adjust it, we can do that. Anyhow, now from here, these are the suction lines. Okay. So what I'm doing, I will be making a vertical pipe. This is my suction header only. Suction line. I'll be making very near to the pump. Here in the vertical, I'll be connecting the pipes. And let me make a section in the front side also. Okay. Now make it fine. This is my suction header. Okay. So I'll be making this as a T-joint. From here, I'll be making a pipe slightly here. And you can cap it. Okay. That is my suction header. And now all this has to be connected to the same pipe. I can make it like a straight pipe. Then I can connect it. But when I am making this as a straight one, in that pipe, I can connect my fittings. But it will consume a lot of spaces. That's why vertically we are taking it upside. Okay. Now I'll be selecting this one. Now we can align this one. Okay. With respect to this one, I have aligned it. The same way, this also. Draw pipe, align to there. Okay. Now you can join it. You can go to this view, trim and extend single element. Okay. So that's our suction header. Primary pump suction header. Now from the primary pump suction, it has to go to the building. Means this is a return only actually. This is return. When we are connecting with the building, machine returns because we are having all these machines in the building. When we are connecting to all these machines, the category will be changing it. Okay. So what I'm doing means I'll be taking my pipe slightly this side. And I'm vertically taking it down. Now it is on ground floor only. From the ground floor, I'll be taking this to minus 500 below the ground floor. Okay. But that pipe is not visible here. No problem. We can. And I have taken my pipe outside through underground. Or through this floor, we can take it down. Okay. Anyhow, I'm just going to the visibility graphics. From the ground floor, this is top offset, okay, ground floor ceiling level. Bottom, I am providing unlimited for time being. Okay. Now, from here, I'll be taking a pipe with respect to the ground floor, just 250 mm above. Then I'll be taking the pipe until there. Now, from this point, we have to take this down. Now, from this point, right click, draw pipe. This is through the floor only. And I'll be taking this into minus 500. Okay. And I can take through this way. This will be underground only. Then it will be coming through this side. Then it is coming to the shaft. Okay. Shaft. Fine. Now all these pipes, we have to provide the thermal insulation. Click tab key. What might be the thermal insulation thickness? With respect to the ASHRAE 90.1, we can select it. Okay. I'm just going to ASHRAE 90.1. Anyhow, at least 25 mm, minimum 25 mm has to be provided. But with respect to the pipe diameter, that will vary. So that's why I'll be selecting ASHRAE 90.1. You can see in table number 6.8.3.1, this one we have used for hot water system insulation, correct? When we are making the centralized hot water system, I guess you still remember, this line, centralized hot water recirculation line and hot water line, we did with the same insulation only with respect to the pipe. Just below that, minimum piping insulation thickness. This one, hot water, it was minimum 25. Pipe fluid temperature between 4 to 16 or less than 4. Less than 4, we are not using now because as per 90.1, the latest standard, the chilled water delta T should be how much? 15 degree Fahrenheit. And the minimum leaving temperature should be 57 degree Fahrenheit. By that scenario, your delta T minus chilled water returned, you'll be getting minimum chilled water entering temperature 5.5 degrees Celsius. So that's why the fluid operating temperature range will come between that. Okay. Minimum piping insulation thickness, if the pipe diameter between 100 to 200, the minimum insulation thickness should be 25 mm. Correct, 25 mm. So this one is like 100 mm pipe only. This one is 100 mm. So that's why 100 mm pipe, the minimum insulation thickness, you need 25 mm. Okay. Fine. But if the material is varying, means it will vary. So you can select this one, like tab key. You can select it. And after that, you can go to the add insulation option, 25 mm. Click OK. Like that, you can add it. But we can add it after providing the fittings and all. Okay. Keep it there. Now, the secondary pump has to be connected. This is primary pump only. And I'll be selecting the secondary pump. Okay, all these 3 pumps I'll be taking there. And we can move it later. I'll be placing it somewhere here. This is my secondary. Now from the chiller outlet, the secondary will be taking the suction. Okay. So let me make the secondary suction. Secondary pump, secondary suction only, but we have to change the diameter. Both I'll be making into suction or discharge 100 mm, 100 mm for time being. But see, design is separate. I'm doing just modeling. At the time design, you have to correct all these things. Okay. This is suction header only. I'll be slightly increasing upside. So all the other pumps, we have to do the same. This is suction. And here as well, we are having suction. Okay. Now let me select this thing, move slightly as well. Okay. Now from the chiller, you can see this chilled water outlet. This chilled water outlet pipe, I'll be taking upside. Okay. There should be spaces to connect the walls and all. Okay. And at the same time, I'll be extending it slightly there. I'll be making a separate section there because I have to witness that. Okay. And let me view that pipe. This is a pipe. Okay. From there, I'll be making this one. This header only, because that is manifold type only, secondary. Yeah, open. It is not dedicated. Primary is dedicated because if the chiller is not working, the primary will be also. And the remaining